Hello everyone, welcome to my channel. Today I am going to explain about stress analysis in pre-stressed concrete beam. Pre-stressed concrete sections, they are analyzed for stresses at two stages, stage 1 and stage 2. Stage 1 is the transfer stage and stage 2 is under working loads. This is at transfer and stage 2 is under working loads. Now, while analyzing the stresses in PSC members, we consider these two stages separately and calculate the various stresses induced. Also, we can find the pre-stressing force and eccentricity by making the standard equations. Now, in the first stage, the factors that we consider as, I have made this one. So, let's see this first. So, in the first stage, there are two parameters, initial pre-stressing force and dead load. Only these two parameters are considered under this stage. Under stage 2, three parameters are there. Final pre-stressing force, which is different. In the problem, it will be given that some losses are induced or 80%, consider 80% loss. So, our final pre-stressing force will be different. Then dead load, same. And one more thing is under stage 2, that is, these are under working load. So we consider superimposed load. So here three parameters are considered. Now, how to solve the problems based on this? Okay, so now we will look here. Suppose this is the cross section of PSC beam and our cable has eccentricity below the neutral axis. So what are the types of stresses induced? So there are three, as we saw that at transfer there is initial pre-stressing force and dead load, and under working loads there is final pre-stressing force plus dead load plus live load. Okay, so this is first stage. This is the cross section of beam. So initial pre-stressing force is always positive. So if we consider this cross section of beam, the pre-stressing force, the stress induced is always positive. That is, stress is force upon area, let's say PO upon A. Then second is due to, now see, if this, suppose our tendon is here, that is, we have concentric cable. So this parameter will not come. Because of eccentricity of this cable, bending moment is induced. Fine. So with respect to neutral axis, eccentricity of the cable induces hogging bending moment, like this, hogging bending moment. So due to hogging, the stress at bottom is compressive, that is plus, and the stress at top is tension, that is negative. Okay, so we can see here the stress diagram, bottom positive, top negative. This is due to eccentricity. So bending moment due to eccentricity. So bending moment is force into distance, that is eccentricity, upon Z. We know stress is force upon area, which is also equals to bending moment upon section modulus, which is also equal to M upon I by Y. So this part we will see later while solving problems. So till now we saw initial pre-stressing force, then due to eccentricity, bending moment induced. Now the third part in the stage 1 is due to the dead load, due to the self weight of the beam, external bending moment due to dead load. Now for a beam, due to self weight, always the bending moment is sagging. the beam sags always due to external loads. So the top surface stress at top is compressive, that is positive, and bottom it is negative. So for this section, top stress at top is positive and stress at bottom is negative. So done. Stage 1 analysis is done. First due to initial pre-stressing force, then due to eccentricity because the cable is below the neutral axis, it is not concentric, and then due to dead load. So our final bending moment diagram looks like this. This part I will explain later. So this was about stage 1. So now while solving problems sigma top and sigma bottom, we have to find stress at top layer and at bottom layer. So 3 parameters come into picture. 1, 2, 3. First is initial compressive force, which is PO upon area, which is always positive. Next is due to eccentricity. Now while finding sigma top, due to eccentricity, hogging bending moment is induced. So the sign will be minus here at top layer. PO into E by Z. Okay. Then due to external bending moment, that is due to dead load only for stage 1. So external bending moment induces sagging, is of sagging nature. So top stress is positive. Moment due to dead load upon Z. So by putting the values of this, we will get the stress at top layer at stage 1. Then stress at bottom layer, same method. Initial compressive force PO upon A. At bottom, eccentricity due to bending moment due to eccentricity, positive sign will come. Now dead load, bending moment due to dead load, minus sign at bottom, MD by Z. So here we will get stress at bottom layer and stress at top layer. Now this was for stage 1. Okay. Now let's look into stage 2, which is under working load. Now here 2 parameters changes. First is initial pre-stressing force with some losses. We here final pre-stressing force is taken into consideration. And one more thing is under live load. So live load factor also we have to consider. So same at stage 2, this is the cross section. Initial compressive force, which is always positive. Bending moment due to eccentricity, same concept. Stress at top minus, at bottom plus. Then here bending moment, external bending moment. Now this is due to dead load and this is due to live load. Okay, now external bending moment is always sagging in any case. Stress at top is positive and stress at bottom is negative. So here external bending moment due to dead load plus external bending moment due to live load. So here while calculation we consider total bending moment. This is the most important part in stage 2. Okay, and the final stress diagram is this. Stress at bottom is 0. So while calculating for stage 2, sigma top and sigma bottom. Let's see now. Initial pre-stressing force always positive plus, but for stage 2 we take final pre-stressing force, which is PF upon A. Eccentricity same, minus PO, same concept as explained earlier for stage 1 plus. Now here instead of MD we take MT. Okay, and for sigma at bottom, initial pre-stressing force always positive, at bottom, final pre-stressing force always positive. Then bending moment due to eccentricity of the cable. Okay, at bottom positive. Okay, so PF into E upon Z. Then bending moment due to external loads, that is due to self weight and due to live load. So it is MT. Here we consider MT. and for bottom it is negative mt upon z. So like this we can find out the stresses induced at top axis and at bottom axis for stage 1 and stage 2. Okay, so this was about the stress analysis. And regarding this, for you have to remember only this thing, that at stage 1 tension comes at top, so stress at top is 0, and at stage 2 tension comes at bottom, so stress at bottom is 0. While solving problems you will get to know more about this. So this was it, and if you like this video then please subscribe to my channel. So thank you.